Hi guys, so today we're going to be learning about geometric mean, and before we start with our example problems, let's define what geometric mean means. So the geometric mean between two numbers is the positive square root of their product. Okay? So for two positive numbers, a and b, the geometric mean is the positive number x where the proportion a to x equals x to b is true. Right? We can rewrite this proportion with fractions, right? A over x equals x over b. And so then with the cross products, it will be x squared equals ab. And to solve for x then, we just need a square root a times b. Okay? So that takes us to our first example problem where we're going to be finding the geometric mean between several numbers. Okay? So here, this is 4 and 9. And so one way to see it is this is 4 over x equals x over 9 to find the geometric mean, which this would give us x squared equals 4 times 9, or x squared equals 36. And then when we square root it, this would be the square root of 36, which is 6. And so the geometric mean for 4 and 9 is 6. Okay, so then let's do 6 and 15. Right? So same thing, or we can just skip it, right? All of this to know that the geometric mean is the square root of the two numbers multiplied together, right? We saw that here, right? It was just the square root of these two numbers multiplied together. Okay? So 6 times 15 is 90. Okay? So square root of 90 would be 3 square root of 10 because 90 is 9 times 10, and then that square root of 9 comes out as a 3. Okay, so this would be the geometric mean. If we wanted an approximation, okay, this is approximately 9.5. Okay. So the geometric mean is 3 square root of 10, or approximately 9.5. Okay. So why don't you try CYP 1A, and then once you're done, come check your answer. Okay, you should have gotten 15 because it's the square root of these two numbers multiplied together. 5 times 45 is 225, and square root of 225 is 15. Okay, so where does this idea come into play? So before we kind of get to that, we are going to talk about the altitude of a triangle. Okay. So consider this right triangle, XYZ. Right? It has an altitude of WZ drawn from the right angle Z, okay, to the hypotenuse. As a result, a special relationship exists for these now three right triangles. This one here, this small one here, and then the original one. Okay? So what we know is that if the altitude is drawn from the vertex of the right angle to the hypotenuse, then it forms two triangles that are similar to the given triangle and to each other. Okay? And so what it means is that triangle XYZ, the original here, is similar to XWY, which is similar to YWZ. And what we know is that the measure of the altitude drawn from the vertex of the right angle to the hypotenuse is the geometric mean between the measures of the two segments of the hypotenuse. So what that means is YW, this altitude, is the geometric mean of the segment it just split, which is the hypotenuse. The geometric mean of XW and ZW here. Okay, so that takes us to example 2. So here we have triangle PQR. We're told that RS is 3. QS here is 14. And we want to find what PS is. Okay. And so what it just told us again is that the altitude right here is the geometric mean of this and this. So PS is the geometric mean, the square root of RS times QS. Okay. So I'm just going to plug in what I know. So RS is 3, QS is 14. 3 times 14 is 42. And square root of 42 is already simplified. Okay. And then if I wanted to figure out what it is approximately, it is approximately 6.5. There we go. In the book, it explains why this theorem is true. And that's because of this idea of similar triangles. Okay. So why don't you try CYP2 and then come check your answer when you're done. Okay, you should have gotten that PS is approximately 1.3. If you got that right, you can move on to the next example. If not, here is your explanation. Okay. So again, the altitude, when it goes from the right angle to the hypotenuse, is the geometric mean of the two segments of the hypotenuse. Okay. So PS then is the square root of 0.8 RS times 2.2 QS. Okay. 0.8 is times 2.2 is 1.76. Square root of 1.76 is approximately 1.3. Okay, let's move on to the next example. Okay. So Mr. Martinez is designing a walkway to pass over a train. Okay. To find the train height, he holds a carpenter square at eye level and sights along the edges from the street to the top of the train. If Mr. Martinez's eye level is 5.5 feet above the street, and he is 8.75 feet from the train, we want to find the train's height, and we want to round to the nearest 10. Okay, so here what we know is that this is a right triangle, and an altitude is formed from his line of sight. Okay, and what we know that a right triangle, when an altitude is formed from its right angle to its hypotenuse, it creates similar triangles. Okay, so this is similar to the original one. Okay, so what I'm going to do is I'm going to draw them separately. Okay, and then we're gonna label its parts. Okay, this is one of them. This is Y, X, W. Okay, we know this is 5.5 feet, right? Because this here is parallel to this. This is 8.75 feet. Okay, and the other one we want to deal with is here. This is Y, this is X, and this is Z. Okay. So this is 8.75. Right. And what we need to know is we need to know what this is. Okay. So here I'm going to label what corresponds to what. Okay. So this short side, this short leg, corresponds to this short leg. Okay. And then this long leg corresponds to long leg. Okay. So then let's set up the proportion. Okay. So I'm going to do 5.5 over 8.75. 5.5 over 8.75 equals 8.75 over my unknown. Okay, you can pick whatever letter you want. Okay, so let me show you how it matched up. Okay, so 5.5 is 8.75, so this one and this, and then it became this one and this one. So this was the small triangle, this is the bigger triangle. Okay. So let's just use x for now because we don't know what this is. So 5.5 times x equals 8.75 times 8.75. Okay. 8.75 times 8.75 is 76.5625. Okay. We're going to divide it by 5.5. And this gives us approximately 13.9. Okay. So this is 13.9 feet. Okay. Which means that this here is 13.9 feet. And if this is 5.5, all we need to do is 13.9 plus 5.5. And that gives us 19.4. Again, because it asks us to round to the nearest tenth. So the train's height is about 19.4 feet high. Okay. So why don't you try CYP3 on your own, and then once you're done, come check your answer. Okay, you should have gotten that the waterfall is 161.8 feet high. If you got that right, you can move on to our last example. If not, here is your explanation. Okay, so here's Michaela using a carpenter's square to sight the top of a waterfall, right? So her eye level is 5 feet above, right? And then she's a horizontal distance of 28 feet from the waterfall. Right? And so this is her looking up at it. Right? So here, and this is her looking down to the ground. So here, this is 28 feet. This is 5 feet because that's where her line of sight is from the ground. Okay? And then up to here, this is the top of the waterfall, which is where we want to figure out. Okay? So then I just separated it again, right? Because her line of sight is an altitude from this right angle to the hypotenuse of the original triangle, right? Which creates two more similar triangles to it. So this one I just separated here. This is the 5 feet, the line of sight, and the 28, the horizontal distance. And then this is the distance again, all the way to the top of the waterfall. Okay. So then this short leg corresponds to this short leg, and this long leg corresponds to this long leg. Okay. And so then I set up the proportion. So 5 over 28 equals 28 over x. Then I cross multiply. 5x equals 28 times 28, which is 74. Divide by 5 on both sides. X equals 156.8. So this here is 156.8. All right, but that's only up to her line of sight. We still need to calculate how long her eye level is from the ground, right? So that's 5 feet. So that's why it's 156.8 plus 5 for a total of 161.8 feet. Okay. And there you go. Okay, so then the last one here, we're going to talk about our last theorem for today. So, if the altitude is drawn, again, from the vertex of the right angle to the hypotenuse, then the measure of the leg of the triangle is the geometric mean between the measure of the hypotenuse and the segment of the hypotenuse adjacent to that leg. Okay, so let's say, what does that mean? Okay, so then here, so what that means, for instance, is that YZ, which is a leg, okay, it's going to be the geometric mean between the whole hypotenuse, all of XZ, times the part of the hypotenuse that's closest to it, WZ. So YZ equals the square root of the whole hypotenuse, XZ, times this part that's closest to it, WZ. Okay? And likewise, XY is going to be the square root of the whole hypotenuse, XZ, times the part that's close to it. Okay? And this explains it why, right? So like XY, what I talked about here, is the square root of this times this. XZ times XW. Okay, there you go. Okay, so that's what we're going to do for example 4. Okay, so it asks us to find x and y. Okay, so what we know then, x here, this is a leg, right? Since in this original triangle, this is the right triangle, this is the hypotenuse. Okay, so that would make x here the leg. Okay, so x is going to be the square root of the whole hypotenuse, PR, which if this part is 2 and this part is 4, that means the whole thing is 6. The whole hypotenuse times the part that's closest to it, which is 4. Okay? So then square root of 24, which is 2 square root of 6, because of this square root of 4 is the 2, and then 6 is only 2 and 3, no pairs. This is x. Okay? And then if we wanted an approximation, 2 square root of 6 is approximately 4.9. So then to find y is the same thing. So y is also a leg, right? So this is the right triangle, right? So this is the hypotenuse. That would make this also a leg. So y equals, same thing, square root of the whole hypotenuse, which in this case is 6, times the part of the hypotenuse that is adjacent to it. So that's 2. 6 times 2 is 12. Square root of 12 is 2 rad 3, right? Because it's 4 times 3, so the square root of 4 comes out as 2. And 2 square root of 3 is approximately 3.5. There you go. Okay. So why don't you try CYP4, and then once you're done, come check your answer. Okay, you should have gotten that x is 4 rad 2, which is approximately 5.7, and y is 4 rad 14, which is approximately 15.0. If you got that right, you can get started on your homework. If not, here is your explanation. Okay. So again, using the theorem that we just talked about, okay, when your altitude goes from the right angle to the hypotenuse, okay, the leg is going to be the geometric mean, so the square root of your whole hypotenuse times the part of the hypotenuse that is adjacent, that is next to it. Okay? So with x here, right, this whole hypotenuse is 16, right? Because if this part is 2 and this part is 14, this whole thing is 16. Okay? So x here is going to be the geometric mean, so square root of the whole hypotenuse, 16, times the part of the hypotenuse that is adjacent to it, right? So that's why it's 2, okay? I didn't have to multiply it because 16 is already perfect square, so square root of 16 is 4, and then 2, not a perfect square, so it stays inside. And then I just typed it in my calculator, and it's approximately 5.7, okay? So y, also a leg, is the whole hypotenuse, so the whole thing is 16, times the part adjacent to it. So this is why this is the part that's right next to it, right? So 14, okay? Then again, I didn't have to multiply it in. 16 is already a perfect square, so that comes out as 4. 14 is only 2 times 7, no perfect squares to take out, so it stays as square root of 14. Plug into my calculator, I get 15.0 when I round. Okay? So that's it for today. Have a great rest of the day. Bye, guys.